Hello everyone, my name is Ritesh Khole and our today's topic for discussion is sound bound. Now, what is sound exactly? So, sound is energy produced when something vibrates in a medium, like we can say solid, liquid, or gas. But sound cannot be in vacuum. So, when something vibrates, it releases its energy into the medium, and this is why the sound energy travels towards us, or we can hear that using our ears, because that frequency with which the object vibrates, and our eardrum can also simulate those frequencies, and then it sends signals to our brain, and thus we can hear whatever is generated, or whatever the we can say the frequency is generated. So, what are we going to study about sound today? So, when there is sound, we usually see Doppler effect in it, or when Doppler effect, we consider the Doppler effect when a source and a observer is there and they are moving towards or away from each other, or all possible cases between both of them. So, let us see. So, this is the Doppler equation in which it is read as F equals bracket C plus or minus VR upon C plus or minus Vs into F naught. Now, these symbols may vary in your textbook, but uh, let us see what are these. So, first of all, C is velocity of sound in that particular medium, we can say, and then we have VR. So VR is the velocity of observer, and uh, plus or minus will be depending upon how the observer is moving, like towards the source or away from the source. We'll see that further. Then we have Vs, which is the velocity of source, and this is also similar, that what sorry, how plus or minus will depend is the source is moving towards the observer or away from the observer. And then we have F naught, that is the emitted frequency. Emitted frequency is the frequency which which source will emit, or emit. We'll see. So now, imagine here is a train engine. Okay, just imagine this is a train's engine, and then it honks its horn from here, let's say. So these waves travel like this. These are the sound waves traveling. And now imagine here is a person standing on, let's say, railway station. So, and the person is stationary, and the engine is also stationary. So the person hearing this sound will hear in its original frequency. But let us imagine, and now this train, imagine this train is again over here, but this time it's moving with a certain frequency towards the observer. So, and if it honks again, so at this time, while the train is moving in this right side direction or towards the observer direction, and observer is stationary, this side waves will be short, or we can say this side, or the towards observer side, the frequency will be more, while away from the observer side, the frequency would be less because it's compressing, or we can say these are generated too quickly in that direction. So, in this case, the observer will hear more number of wave or more frequency than the stationary one. That's why in our equation, when we are here, we can see it's the observer. So observer is not moving. That's why it would be 0. And then when source is moving towards the observer, the velocity will add. Understand? This will add. And now we'll see how or what will happen if train moves away from the observer. So now this time, let's say this is our train again. Here are the wheels of the train's engine, and this time imagine it's moving away from the observer, and that's why in this direction the frequency of waves generated would be more as compared to this, as I told a few minutes ago. And that's why, oh sorry, and that's why our observer here would hear less number of frequencies generated as compared to this side. And that's why in our formula we will have negative sign over here, whereas 0 over here, because our observer is not moving anywhere. And now let us consider now the engine to be stationary, railway's engine to be stationary, and observer to be moving. And let's see what happens in that case. Now, similar in the similar way, now let us consider our this engine to be stationary in one place and observer to be moving. If the train honks, the waves are moving with the same frequency, and this time not generating different frequencies for because it is stationary. That's why all the frequencies in right side and left side will be generated is same. Now the observer is moving this time, so it will hear every or the waves reaching towards it would be early, or each wave he would listen would be early because he is moving towards that. So in this case, we can say that our this formula, and here this is 0 because it's not moving, source is not moving, our engine is not moving, and this time observer is moving towards the source. That's why we'll have a plus over here. And in similar way as we discussed, when this observer would be moving away, and this is the same engine but stationary, and this time also waves generated would be same, but each time he moves uh, ahead, each wave would be reached to him a slightly different times. So that's why we will use a negative over there. That's why here we will have minus. But what if both are moving Now let's consider that also. So let us see. This is the engine and this is a person. And now engine is also moving. So here frequency generated is already more as compared to this side, and this will already add, as we have seen in our first case. This formula will have already an addition symbol over here, and then this is also moving in the, not towards, both are moving towards each other. So she will also hear number of frequencies to be more. That's why in our formula now we will have both of them to be plus, and in similar way, if both are moving away from each other, then we will have a negative sign over there. Now here is an experiment, an interesting experiment for you all. So let us see what is it. So take a sock, a long rope, and a handy alarm clock. Now the procedure is, set the alarm clock to any time that is 3 minutes later than the time of conducting the activity. Now place the alarm clock in the sock and tie the open end of the rope. Like you have to tie the sock so that it should not fall away from the sock. Now tie the other end of the rope at an elevated position so as to make a free swinging pendulum. You know what is a pendulum. So now just hang it in a way such that when you move it, it will move in a pendulum, like a pendulum. Now generally push this sock in an oscillatory motion. As soon as the alarm rings, close your eyes and carefully listen to the sound. And now note when the sound is maximum and when it is minimum. So make the clock swinging higher and make note of all your observations. Now we can here observe that when it is in front of us, it will be having the maximum, what we can say, its sound would be maximum, and when it is at an swinging position, it will have a less sound. So this is our observation right now. Now Doppler effect is an increase or decrease in the frequency of sound, light, or other waves as the observer and the source of sound or light moves towards or away from each other. This is what right now in the first formula we just saw, that velocity, and this is the emitted frequency, and this is what the observer will hear or see, whatever. Then it is the most commonly observed in railway platforms as trains come and go, and the similar example we have taken right now for our discussion. Now, here's a question under this think time. Discuss how metallurgists use Doppler effect to analyze weather events, and how a Doppler echocardiogram use sound wave to produce images of heart. Now, they do it in a way like they send the sound signals in air, and they just monitors how the drops are moving, or drops of precipitations move in the in atmosphere, and when they track about the movements simultaneously. And that's why this helps in predicting what would be the weather at any next point of time. And now the second question, how a Doppler echocardiogram uses sound waves to produce images of heart. So in echocardiogram, it usually uh, uses ultrasonic waves for observing how the blood flow is through the heart, or how a blood flow moves in heart, or how much blood flow is there in there. And it also creates the images of heart with this Doppler technology. So this is for today. Thank you everyone. If you have any questions, you can put that in comments. I'll definitely try to answer them. Thank you.